instructions to see which you're looking for. Okay, so first I do want to go over arc measure since it's a little bit easier to do. So first thing we have here is called a central angle. Okay, that is an angle whose vertex is at the center of a circle. Okay, so your central angle has a vertex at the center of a circle. So if I look at the picture at the right here, where I put this X, that would be a central angle. Okay, so it's made up of two radii in your circle. How many degrees are in a circle? 360. Okay, so there are 360 degrees in a circle. That means the sum of your central angles all have to be 360 degrees. Okay, so if you're missing some of your central angles, you can use that all of them have to add to 360 in order to find that missing one, which is what we're going to do in number 4, A and B there. We're going to find the value of X for each of those circles. So in letter A, X is right here. I know this angle GFH is 130 and this angle JFH is 90. Okay, so all three of those central angles have to be 360 degrees. So I can just subtract the two that I know, which is 130 and 90, to get that X value of 140. Okay, then in letter B, we're going to do the same thing. So we're looking for the value of X right here. This angle is 85. This one is 40. Again, this one is 90. So all we have to do is take 360, subtract the angles we already know to solve for that missing angle of 145. Okay, so again, those are all central angles. Okay, they come from the center of the circle, hence central angle, from the center of the circle. All right, then we're going to move into our arcs. Okay, so an arc is a portion of a circle defined by two endpoints. Okay, a central angle separates the circle into two arcs. So over here, you have a central angle PQR. Okay, that separates this circle into this first arc right here and this second arc over here. Okay, so your angles separate the outer part of your circle into arcs. So we are going to look at arc measure next. Okay, so the measure of each arc is equal to the central angle. Okay, so they're just equal to each other. So if I know arc or the central angle PQR, if I know it's 130, okay, that means the arc across from that, or the arc that's intercepted by that central angle, is also 130. Okay, so again, that's with a central angle. Later we'll get into different kinds of angles, and that's not the case because it's not from the center. But for today, if you have that central angle, it's the same. Okay, and this one is the measure. So if it asks for the measure of the arc, it's the same as the central angle. So we do have different kinds of arcs. laid out in this table below here. The first type is a minor arc. Okay? Minor arc is the shortest arc connecting two endpoints in a circle. It has a degree measure less than 180. Okay, so your minor arc is less than 180. So in the picture there, if you have a central angle of x degrees, this would be your minor arc. Okay, it's less than 180. Now when you're labeling a minor arc, it's named with two letters. Okay, so you label a minor arc with two letters. In the picture at the right there, I would say this is arc A, B. So you use those end points of that arc. And then just like with our segments, we do have a symbol that goes over the top. You just draw an arc over those two letters there. Okay, our next type of arc is a major arc. Okay, so we have a major arc. Your major arc is going to be greater than 180 degrees. Okay, so in your picture at the right, a major arc would be this one back here. Okay, so it's greater than 180. Now, major arcs are named with three letters. Okay, so minor arc was named with two letters. This one is named with three letters. So, kind of like our triangles, you have to go in order for your major arc. So you always want to start at one of the end points and then go around that arc. So I could label this arc A, D, B. Okay? So your two end points should be at the ends. Okay? And then you'll have a middle point in the center of those two letters. And then you just go in that order. Okay, the last type of arc we have is a semicircle. Okay, that measure is 180. Okay, specifically, it is 180. It is formed by the diameter of the circle. Okay, so here in my picture would be a semicircle. Okay, with endpoints on the diameter. Now, a semicircle is also named with three letters. Okay, so it's also named with three letters. And just like the major arc, it has to go in that order. So you need to start with an endpoint and end with an endpoint. So for this one, again, I could start at A, go around to D, and then to B. So we have arc A, D, B. Now you could start with B. Okay, you could also say this is arc B, D, A. Okay, you just need those endpoints to start and finish. Any questions on your three different types of arcs? All right, then at the bottom there, I do have some examples. So this one says that PM is the diameter of circle R. Okay, so PM right here is a diameter. We want to identify each arc as major, minor, or semicircle. Okay, and then find its measure. So again, its measure is the same as the central angle across from it that intercepts that arc. So first thing I do when I see problems like this is I find all of my missing angle measures, all those missing central angle measures. Okay, so I know this angle right here with the box is 90. I know PM is a diameter, okay, so it's a straight line. What does a straight line have to equal in degrees? 180. So if this angle is 90, what does this angle have to be? 90. Okay, same thing over here. These two angles have to add to 180 because they form that straight line. So I can take 180 minus 115 to get this missing angle right here. And that's 65. So again, first thing I do is find all of those missing angles in that circle, so then I can just focus on those problems. So in number 2A right here, we need to label this as minor, major, or a semicircle first. So arc MQ. Which one of my arcs is the ones named with 2 letters? Minor. So I don't even have to look at my picture to see that this is a minor arc. Okay, it's labeled with 2 letters. Okay, then I want to know the arc measure. Okay, so MQ is this arc right here. Its central angle is 65. That means its arc measure is 65. Okay, 2B, we're looking at arc M to N to P. Okay, M to N to P. Which type of arc is that? Semicircle. Okay, and what does its degree have to equal then? 180. Good. Okay, then our last one is arc M, N, Q. Okay, so all the way around the outside here. Okay, that arc is greater than 180, so it is a major arc. Okay, then to find that arc measure, I can either add all 3 of these central angles together, or since I know the total circle has to be 360, I can just subtract the missing arc, which is 65, from 360. Okay, either way will give you that arc measure. So if I take 360 minus 65, that's 295 degrees. Or again, you could add 90 plus 115 to get that total arc as well. Questions on your arc measure? Okay, arc measure is the same as your central angle measure. All right, so just like we had congruent circles, we can also have congruent arcs. Those are arcs in the same or congruent circles that have the same measure. Okay, so your arcs have to have that same measure to be congruent arcs. So in the same circle or congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. Okay, if and only if, again, means that you can read this statement from the front to the back and then backwards, so from the back to the front as well. So I'm going to show you that in 2 things here. So if I have angle 1 congruent to angle 2, right? Those 2 central angles are congruent. That means the arcs across from them have to be congruent. So I would say arc FG is congruent to arc JH. Okay, so since those 2 angles are congruent, their arcs have to be congruent. Okay, and the opposite is true. So if I know that those 2 arcs are congruent, okay, so I knew that those 2 arcs were the same, then I could say their central angles are also the same. So angle 1 would be congruent to angle 2. Okay, that's what that if and only if means. You can do it from the angle to the arc and then the arc to the angle. All right, so remembering back to your segments or your angles, okay, that we did at the beginning of the year, so in semester 1, we had adjacent angles and then adjacent segments. Okay, adjacent again means next to each other. Okay, so we have adjacent arcs here. Those are arcs that are next to one another. Okay, making sure you remember what that adjacent word means. So that means they have exactly 1 point in common. Okay, so 2 arcs that share 1 point. So we can use an arc addition postulate just like we had a segment addition postulate and an angle addition postulate. Okay, that means we could add the 2 angles that were next to each other together to get the entire one, or the 2 segments that were next to each other to get the entire segment. Okay, same thing with arcs. So it says the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. Okay, so again, we can just add the 2 arcs that are next to each other or adjacent to each other to get the total measure of that entire arc. Okay, so we're going to do some examples of that in number 12. We want to find the measure of each of these arcs. So again, first thing I do is find all of my missing central angles in my picture so that I can find each measure a little bit easier. So this angle, again, is 90, right? If AC is a diameter of my circle, how can I find this missing angle right here? Yes. So subtract 90 and 63 from 180. That will give you this smaller angle here. Okay, that's 27. Now BE is also a diameter. Okay, so what you could do is take these 2 subtracted from 180 again to get this one, or you could notice that these 2 are intersecting lines. Then these 2 angles are vertical angles, meaning what? They're congruent. Okay, vertical angles are congruent, so this angle would have to be 63. Okay, so you want to look for those vertical angles in these pictures as well, if you know those 2 lines or segments are diameters. Okay, then the last angle here, again 63, and this angle that I'm missing, have to add to 180. Okay, so subtract those, that is 117. So now that I've found all of my missing angles within that circle, I can find my arc measures. So letter A, we're finding CE. Okay, so I'm going this way because I know it's a minor arc, because it's labeled with 2 letters. Okay, I'm not going to go this way around because that would be greater than 180. Okay, we need to make sure it's less than 180, so that would be this one right here. I have 2 adjacent arcs. I can add those together to get the total arc, so 90 plus 27 is 117. Letter B, we're looking at the measure of arc ABD. So from point A to point B to point D. So I have 3 arcs in a row for that one. All I have to do is add up all 3 of their measures. So 117 plus 63 plus 27.
Good morning. We're counting for FFA, so raise your hand if we're in red, white, and blue. All right. Thank you.
Okay, so after I add all of those together, I get 207. Okay, then letter C, we're looking at arc AD. So again, I'm going to find the minor arc since it's labeled with 2 letters. So from A to D, that would be this one right here, not this one around the back. That would be greater than 180. Okay, so here I'm going to add 90 plus 63 to get 153. Then my last one, letter D, the measure of arc ADB, so all the way around here. Well, the only arc that I'm missing from that is 117. Since I know all of these have to add to 360, I can take 360 minus 117 to get that arc. Or you can add them all together. That would work too. And you do get 243. Okay, questions on your adjacent arcs? Okay, so that was all arc measure. Okay, you also have arc length. Okay, they are different. Okay, so now we're going to look at arc length within your circle. So again, you need to read your directions carefully on your assignment. Some of them ask for arc measure. Some of them ask for arc length. Okay, arc length is part of the circumference. So that means you're going to need to use the circumference to find that length around that piece of that circle. So it is a fraction of the circumference. Again, part of it, it'll be a fraction of that circumference. So since circumference is a linear measure, arc length is also a linear measure. Okay, so if you're finding circumference, it's nothing squared. You're not squaring or cubing anything to find it. So your arc length, you're not squaring or cubing anything to find it. Okay, it's just linear. So our formula for arc length is a fraction times the circumference. Okay, so it's the central angle measure. Okay, so the measure of your central angle divided by 360. Okay, so you're taking that central angle and dividing by the total of the circle. Then you're multiplying by the circumference. Okay, or you can think of it like this over here. So you have x over 360 times 2 pi r. Okay, where x is your central angle. Okay, and 2 pi r right here is the circumference. Okay, so we're just using this formula to find the arc length. So we're going to go through some examples of this. So we want to find the length. So again, looking at your directions, find the length of arc ZY. So that would be this arc right here. So just using my formula that I highlighted right here, we need the central angle of that arc. That is 75. It's divided by 360. Then we're multiplying by the circumference. So we have 2 pi, and r is your radius. Okay, I'm given the radius is 4 inches. So I would plug in 4 for r. Okay, then you can plug that into your calculator. You do have to be careful of how you plug this in. Because if you do it all in one, you need parentheses around your fraction. Okay, So what I would do is take 75 divided by 360, and I'd press enter and get that decimal, okay? So I would just do that part first. Then I wouldn't clear anything out, okay? I just multiply right away. That way it takes my answer that I got, and I'd multiply by 2 pi and 4 to get my answer. Okay, and you should get 5.24. Now, since my radius was in inches, my arc length should also be in inches. Okay, we're going to do one more letter B on this page right here. So we're trying to find, again, the arc length of ZY. Okay, so that's that length right there. So we need the central angle, that's X. So our central angle to that arc is 130. Divide that by 360 to get that piece of that circle. Then we're multiplying by the circumference. So in this one, the diameter is 10. So if you want to use 2 pi r, your radius would be 5. Okay, so I would multiply by 2 pi times 5. Or if you realize circumference is also pi times diameter, you could write it as 130 over 360 times 10 pi. Okay, either way, you're going to get the same answer. But when you're given that entire diameter and you want to use 2 pi r, you need to find r. Okay, meaning you have to divide the diameter by 2. So again, make sure you can enter that into your calculator correctly. Okay. You should get 11.34 centimeters. Okay, so again, make sure you are careful when entering in your values. Any questions on those two problems? All right, then I want you guys to do number 3 on the last page. Okay, do number 3 on the last page. Use what it's giving you. You have to find the length of that arc. So find the length of arc BC, so locate that arc. And you want to round to the nearest hundredth. So you need to find that angle measure, which they gave you already. It was a bad problem to pick. And then use that BE as 24 feet. All right, so number 3, your central angle is 45 degrees. Okay, so I plugged in 45 for that x value in your formula. Then BE is the diameter. So they gave you the entire diameter. So I can just take that 24, multiply it by pi, or you could write it as 2 pi times 12 if you found that radius then. After you enter it into your calculator, you should get 9.42 feet. Okay, so again, make sure you can enter that correctly in your calculator. Any questions on arc measure or arc length? Okay, again, make sure you are reading the directions carefully so you know if you're finding the measure or the length in your assignment. Okay, if it helps, highlight your direction where it says measure or where it says length, or circle it or underline it, anything like that.